Good morning, everyone. Today we have to discuss pro- design a sequence detector to detect a sequence 101 using D flip-flop. As the sequence detector is nothing but the sequential circuit, so before while designing the sequence detector to detect the sequence 101, 101 is nothing but the 3 bits. Hence, first we have to consider the given sequence is of 3 bit. Hence, we require 3 states in the state diagram. Let A, B, and C are the 3 states. So, while designing the sequence detector, we have to first draw the state diagram for the given sequence 101. So here there are the 3 states A, B, C. A is the first state, B is the second state, and C is the third state. As we draw the overlapping sequence with the help of the Mealy FSM, as there is the first bit is nothing but the 1. If 1 is detected from the present state, we can move forward in the next state 1, and B has the value 1. But if there is the 0 is detected, 1 is detected, we can move forward. But if 0 is detected, this state we cannot move forward, so we have to remain in the same state if 0 is detected. So this A state we have considered this state has the value 0, as these are the inputs and both the inputs have the output 0. Why 0? Because we cannot, because output is 0. When we detect the complete sequence 101, then only the output is 1, otherwise it is remains 0. So now in the B state, next sequence is, we can write down here, if 1 is detected we can move forward, and if 0 is detected we can remain in the same state. Now in the, if 0 is detected, we can move forward, and this C has the value 1 0. So if 1 0 is detected we can move forward, but what happens if 1 1 is detected? So if 1 1 is detected, this state has value 0, this state has value 1, so we required single 1, so we have to remain in the same state 1, and both the input have the output 0. Now what happen if in the C state? If the C state, what is the next bit? 1. So 1 0 1, next bit is 1. So we have to first check whether the state having the 0 1 sequence. No state has the 0 1 sequence. Now check the only 1. This state has only single value 1. So 1 0 1 1 0 1, so we have to move to the B state, then only the 1 is detected. If the complete sequence is detected 1 0 1, then the output is 1. Now what happen if 0 is detected, 1 0 0? Now we have to check whether the state having 0 0 value, no state having the 0 0 value. Now check the single 0 value, this state having the single 0 value. So 1 0 0, we can move to the A state. So this is nothing but the input 0 and output also 0. This is nothing but the state diagram of the given sequence 1 0 1. Now let us consider three state. A have the bit sequence 0 0, B have the bit sequence 0 1, and C have the bit sequence 1 0. Also we have to consider the present state and the next state. Let Q2 Q1 are the present state Q2 plus and Q1 plus are the next state. X be the input and Y be the output. This all the things we have to consider. Now from the state diagram we have to write down the state table. State table. In the first column, this is nothing but the present state. In the next column, this is nothing but the next state when the input is equal to 0 and when the input is equal to 1. And the third column, this is nothing but the output. We have considered the output y when input x is equal to 0 and x is equal to 1. Now from the present state, we have considered the three states A, B, C. When A is the present state, when input is 0, what is the next state? A. And if input is 0, output is also 0. When A is the present state, when input is 1, what is the next state? B. And if the input is 1, then output is 0. Now in the B state, if the input is 0, next state is C. And at the same time output is 0. If the B is the present state, next state is B when the input is 1. And at the same time output is 0. Now in the C state, when input is 0, next state is A. At the same time output is 0. If C is the present state, next state is B when input is 1. At the same time output is 1. This is nothing but our state table. We have written the state table from the state diagram. Now after the state table, we have to write down in the question is given to detect the sequence 101 using D flip-flop. So we require the excitation table of D flip-flop. We already know the excitation table of the D flip-flop. D is the input of the flip-flop. Let Q1 is the present state, Qn plus 1 is the next state of the flip-flop. So this excitation table has the 2-bit combination input. As we already know, in the excitation table of the D flip-flop, next state and the input to the flip-flop are same. So this is nothing but the excitation table of the D flip-flop. Now with the help of the excitation table of the D flip-flop, we have to write down the excitation table of the state diagram. Excitation table of state diagram. In the first column consists of the input value x. In the second column, present state. We have considered the present state Q2, Q1. In the next column, it consists of the next state. We have considered the next state Q2 plus and Q1 plus. The third column, it consists of the input to the flip-flop. So there are the 2-bit combination, so we require the 2 flip-flop. D2 and D1 are the input of the flip-flop. And last column consists of the output Y. So input X, Q2, Q1, here we can write down the 3-bit combination truth table. In the next state, if input X in the next state column consists of the bit combination, we have to write down fill the column in the next state using the state table. We know the state table of the we already write down written the state table of the state diagram, present state, next state, output Y. If input X is equal to 0 and A, we have considered the A value, that is 0 0. Next state is also A means 0 0. If input X is equal to 0, if B is the present state, B has the value 0 1. Next state is value C. C is nothing but the 1 0. If input X is equal to 0, C is the present state, C has the value 1 0. Next state is the A has the value 0 0. 1 1 state is not considered in our problem, so we have to write down the don't care. If input 1, if A is the present state, that is nothing but the 0 0. Next state is the B is nothing but your 0 1 bit combination. If A is not, if input X is equal to 1, B is the present state, next state is also B is nothing but the bit combination 0 1. If input x is equal to 1, C is the present state, next state is B. B is nothing but bit combination 0 1 and 1 1. We don't consider the 1 1 in the state diagram, so it is nothing but the cross mark. Now we can also already explain the output y in the state table. X is equal to 0, then output is 0 0 0. When x is equal to 0, then output is 0 0 0. And when x is equal to 1, then output is 0 0 1 0 0 1. Now input to the flip-flop is nothing but the column. We have to write down the column with the help of the excitation table of the D flip-flop. See the excitation table of the D flip-flop. Input to the D flip-flop and the next state column both are same. So in this also next state column and the input to the flip-flop, both the columns will remain same. You can check present state 0, next state 0, then input to the flip-flop 0, present state 0, next state 0, then input to the flip-flop is 0, present state 0, next state 0, then input to the flip-flop is 0. If present state 0, next state 1, 0 1, then input to the flip-flop is 1. If present state 1, next state 0, for 1 0, input to the flip-flop is 0. Similarly, these two columns are same. Similarly, we can write down 0 0 0 1 0 1 0 1. So this is our excitation table of the state diagram. Now we have to draw the K-map for D2. As it is the 3 variable K-map, inputs are x, q2, q1. Zero, 1, 2, 3, 4, 5, 6, 7. In the D2 column, 0, 1, 0, 0, 1, 0, cross mark, 0, 0, 0, cross mark. Here we can make the group of 1 and cross mark. Its equation is 0 0 same, that means x bar, and for the 1 that is nothing but the q1. This is the value of the D2. Now next is nothing but the K-map for D1. X, q2, q1. You already know the K-map of the 3 variable. Now see the column of the D1, 3 times 0, cross mark, 3 times 1, and cross mark. Here we get the group of 4. The equation of this is the K-map for D1. So the value of the D1 is nothing but the 1 1. Corresponding variable is x. There is no value. So D1 is equal to x and D2 is equal to x bar q1. Finally, we have to also draw the K-map for output y. x q2 q1 0 1 2 3 4 5 6 7. So see the column of the output y, 0 0 1, and last cross mark. Here we get the group of 1 cross. The value of the output y is nothing but the 1 corresponding variable is x into q2. So these are the three values of the k-map d2, d1 and output y. Now from this value we have to draw the designing of the sequence detector using D flip-flop. This is the flip-flop number 1, this is the flip-flop number 2. Its input is D2 and output is Q2, Q2 bar. This is the flip-flop has input D1, output is Q1, Q1 bar. Flip-flop, flip-flop. So this two flip-flop has the same clock pulse. Consider it is the negative edge triggered. This is the clock pulse. It is nothing but the synchronous circuit. So both the flip-flop has common clock pulse. So see the value of the D2 value of the D2 is nothing but the X bar into Q1. So suppose this is nothing but the input X. So output of the NOT gate is nothing but the X bar. X bar into Q1, that means we require the one NOT gate. This is nothing but the X bar into Q1. See the value of the D1 value is X. So value of the D1 is nothing but the X. So and finally the value of the Y is nothing but the X into Q2. Output Y has the value X into Q2. This is nothing but the X multiplied by Q2, X into Q2. So we require the one AND gate. So this is nothing but the designing of the sequence detector using the to detect this using D flip-flop to detect the sequence 1 0 1 logic diagram. So you can practice more example by taking the different sequence. Thank you.